Hi, just a quick look at P2 Topic 6. Last minute revision or a quick 5-minute review of what you've done in class. P2 Topic 6. We're looking here at radioactivity, radiation, and the applications and the risks and the hazards and the precautions you have to take when we're working with these kind of stuff. So let's start with the hazards, the dangers of ionizing radiation. So let's start with a person, and this person might be a radiation worker. They might work in a nuclear power station or a nuclear submarine. They might work in a hospital which uses radiotherapy to help people, and so not a very good picture there, I'm afraid. But if this person is exposed to any form of nuclear ionizing radiation, which can take the form of alpha or beta or gamma, then this person is going to be exposed to some risk, but different risks according to the type of ionizing radiation. Alpha is stopped by the skin, so it's not going to penetrate the body and cause any deep damage. However, it can hit the skin. It's very ionizing. It's got a +2 charge, which means it'll pull electrons off any atoms that it hits. If this was air, it would get stopped by just a few feet of air, so the source would have to be very close to the skin here. But the skin would stop the radiation. You would get some radiation burns, maybe some damage to the skin cells. What can happen is that the ionizing radiation, whether it's alpha, beta, or gamma, could hit the atoms in your body. They could cause ionization. And that could ultimately result in a disruption to cell division. So if the cells divide and reproduce and make new cells, as they do all the time, then it could potentially make a mistake when it replicates in the DNA, and that's what we call a mutation. That mutation could potentially cause problems like a tumor or a growth, the type of cell that we don't really want. The second type is -1 charge, a fast electron from the nucleus of a radiation source, and this would penetrate further, possibly into the skin, into some of the tissues. Again, we could cause cell damage, same thing, ionization, mutations, etc. Finally, gamma. Now, we are being bombarded day in, day out, every second of our lives by gamma, because gamma waves come from outer space, cosmic rays from exploding stars and whatnot. So our bodies are constantly mopping up any damage caused by gamma or cosmic rays. They are only, thankfully, weakly ionizing because they haven't got a charge, but what they can do is hit an atom, give some of the electrons some extra energy so that the electrons can leave the atom, leaving behind an ion, which results in damage. So they might, they certainly actually, they're very penetrating. They might well pass through your body without causing any problems at all. However, if they do interact with some atoms inside your body, they might cause some ionization, again, some cell division problems. They might cause mutations and health problems like that. That's if the source is on the outside. It's actually a totally different story. If this person, let's say this person was poisoned by drinking or eating a radioactive substance. So starting in the stomach, the alpha wouldn't get out of the body, so all the damage that alpha caused would be caused inside the body with the internal organs. It would cause, wherever it went, it would cause damage internally. That's pretty bad. So on the outside, alpha isn't too bad. It can't get in the body, but once it's in the body, all the damage is caused inside the body. Beta, it can again cause damage inside the body. All the damage is probably going to be caused inside the body. Gamma, not as bad. We can actually inject people with gamma. We do that in terms of radioactive tracing. A weak gamma emitter that would quickly circulate all around the body if it's injected into the bloodstream, and then gamma would be given out, and a weak source wouldn't cause too much damage. We would hope there would be a small risk, but by doing that you'd be able to see the blood flow around the body and see if there was any problems with the circulation. So we're looking at here the exposure, radiation workers, and what we might have to do. They might have to wear goggles or use tongs when they're handling radioactive sources. They might have to wear protective clothing, and they might definitely have to wear some kind of a badge to monitor their exposure to radiation and have their health checked regularly. If a person is poisoned, it's a bit of a different story. We didn't know about all of this for quite some time. It was probably, sort of 100 years ago. We were really starting to play around with these radiation sources, but we didn't really understand the dangers too much. So, radium and stuff like that, great paint that glows in the dark. Whoa, we stuck them on alarm clocks and stuff like that, and they're constantly giving out radiation. And the people in the factory who painted the radiation paint, the radioactive paint on the hands of the clocks, which glowed in the dark, mostly women, and that was just the case back then, and they used to also lick the brush as they were painting, and they found, after about a few years, that a lot of these young ladies were getting ill for no good reason, and eventually they traced it back to the fact that they were being exposed to this ionizing radiation from the radioactive paint. Also, I mean, if we look at Marie Curie, the first woman to win Nobel Prizes in physics and chemistry, and she died of radiation exposure, because she'd been working with this stuff for years. So we did cotton on to the fact that this stuff wasn't good, and we do still use it because it does have its useful applications, but the people who are working and exposed to radiation take precautions, quite rightly. I'll leave that there for now. That's a little bit on topic 6. I might add some more at another time. Thank you.